Hi there. So in this video, I'll try to solve some maths from this. If you say uh, from this part here, right here, from question number 49 to 60, this is the question in problem 49 to 60. For each of the polynomial function, we have to do a couple of things here. Let's do 49 number first from this worksheet. Let me write the question first. I will write the question and then I'll try to solve it so that it makes some sense. So 49 number question is fx equals to 3 into x minus 7 then x plus 3 whole square. This is our question, and this is our the given function, and the first question is list each real zero and its multiplicity. So we have to find out the real zero, and from the definition of real zero we know that real zero will come from this one, and we have to find out for which value this function becomes 0. So let's find a number real zero. To find the real zero, we have to consider this equals to 0. So we get 7 here. That means if we put 7 here, and you can see if we put 7 here, 7 minus 7 equal to 0, then 0 into the whole thing equal to again 0. And another real 0 will come from x plus 3 whole square. And if we send this square to the other side, it becomes a square root of 0. Square root of 0 equals to again 0. Then x equals to minus 3. So these are two real zeros for this function. And what is the multiplicity? So you can see multiplicity is the power of the factor. So this is a factor and power is 1. That means multiplicity here is 1, and in this case multiplicity is 2. So this is their multiplicity. Multiplicity is just the power of this. This is 2, so multiplicity is 2, and power of this is 1, so this is multiplicity is 1. Then comes the second question. B number question is determine whether the graph crosses or touches the x-axis at each x-intercept. So B number, you see at x equals to 7 what happens. So at x equals to 7, the graph. So the rules which is actually working in this section is if we have the multiplicity odd, then at that point the graph will cross. So the graph will cross, and if the power is 2, then a graph will touch. So at x equals to minus 3, the graph will touch. Then let's do C number question. C number question is determine the behavior of the graph near each x-intercept. So now we have to find out the behavior. So how do we find the behavior? Let's give a try. So let's find out first at x equals to 7. What happens at x equals to 7? That means we have to put x equals to 7 in the question. So what happens is if we put x equals to 7 in this function, we cannot put it here because we obtained x equals to 7 from this value, and if we put it again, this becomes 0. So it will become 3 into x minus 7 into then 7 plus 3 whole squared. Now you see 7 plus 3 means 10 square means 100 into 3 means 300. So this thing comes 300 x minus 7. 300x minus 7, this term is basically some positive number and then some x, which is, it means if you consider y equals to this into this, so basically this is some straight line having positive slope, and this will be like some straight line having positive slope. The slope is actually a huge number, so it will be like kind of too much. The slope is huge, so that means it will be too much vertical, kind of not a vertical line, but it will be much vertical than the regular one. I mean, what I mean, it will be really close to y line, but not y line. Basically, this is simply it is a straight line having positive slope. We can just say it this way. Then at x equals to -3, what happens? So we have to put now -3 in the function. So it becomes fx equals to 3 into -3 minus 7, then x plus 3 whole squared. So if we do the calculation, -3 and -7 becomes -10. -10 into 3 means -30. So this is -30 x plus 3 whole squared. And this is actually a parabola having negative some coefficient. That means it is a down opening parabola. So this is the behavior at these 2 points, at these 2 x-intercept. Now we have another question, which is determine the maximum number of turning points on the graph. So this is the number. Let's try to do the number here. Maximum number of turning points, and maximum number of turning points actually comes from the degree of the function. So the degree of this function is, here it is 2 and here it is 1, so total is 3. So degree is 3 here. As the degree is 3, so the turning point, the rules here is the theory here is, if the degree is n, then the maximum number of turning point will be n minus 1. As here the degree is 3, so turning point will be 2. That means there will be 2 turning points for this function. Then in number, they say determine the end behavior of this function. So end behavior is simply the power function of the graph. So you see there is x and there is x square, so total it will be x cube, and there is a constant here, so we have to combine all of this, and it becomes fx equals to 3 x cube. So that is our end behavior, and this actually means something like some cubic function. So end behavior will be some cubic function. So cubic function is like that. Now I want to we want to extend the questions. Actually in this chapter the question is up to here, up to if you see up to e number. So we will extend it and we will try to do it another 2 steps. Let's say f number. Let's say we want to find out the y-intercept of this given function. So y-intercept, to find the y-intercept will be x equals to 0. To find the y-intercept, we find x equals to 0. So y-intercept will be fx equals to 3 into 0 minus 7, then 0 plus 3 whole squared. And 0 plus 3 means 3 square means 9, then there is 3, there is minus 7. If we multiply all of them, then answer comes somewhat 189. 3 into minus 7 into 9, answer is minus 189. That is the y-intercept of this function. Now I'm interested to draw the graph and to see how the graph, what type of graph we are going to get here. We are interested to see it. Let's draw the graph of this function, though it is not needed actually according to this question, but we are interested to draw the graph of this function. So if I want to draw it, then let's draw the axis, then this. Drawing this graph is kind of okay. Can I draw it here? All right, I am just what to do with it. This is kind of a bit uncomfortable to draw it there. Anyway, let's try to draw it. Let's try to draw it because it is just freehand drawing. So basically this is our x-axis, this is our y-axis, this is our y-axis. Now now we have to go to this x equals to 7. So x equals to 7 means, let's say 1 2 3 4 5 6 7. So 7 is here. Then we have to go to x equals to minus 3. So minus 3 is 1 2 3. This is our minus 3, this is our 7. Now we have a problem here, and that problem is our y-intercept is minus 189, which is a kind of very big number for this graph. So we will change the scaling. Let's say this is minus 100 and this is minus 200, and in the same way this will be plus 100 in the y-axis if we follow that. Not only if we have to follow the same scaling for the y line. Now look at the behavior. What we had here is in the y line we have something at x equals to 7. This is actually some positive slope straight line. That means at x equals to 7 the line is like this, and at x equals to minus 3 this is some negative opening parabola. So negative opening parabola means like this, down opening parabola. And we have some y-intercept is minus 189, which will be somewhat here. And then we have our end behavior. End behavior is this. So you see the arrow, end arrow will be like this, something like this, and end arrow will be like this, somewhat like this. So this is our end behavior. Sorry for this. Now you see the shape of the graph. You see the shape of the graph like this. So that will be the shape of the graph. So just now we can fill it up, then we will get the graph. We will get the graph. And if you want to draw it, like we are not sure if the graph is going to this point or somewhat in some other place. If we want, actually we can check it by putting some points and then trying to understand through which the graph goes. But we are trying to draw some estimated graphs, some rough estimation for the graph, so that we get it some sense of the graph. But if we want, then we can actually plug in some, let's say x equals to 1, x equals to 2 in the question, then where the value of y comes, then we can get. But this is some rough estimation of the graph, but the graph will be somewhat like this. And you can see now, you see the d number question, which is total number of turning points, and you see total number of turning points is matching with this graph. One turning point is here, another turning point is here, so only 2 turning points in this graph, which is actually matching with this. So this is for n number maths. I hope this works and this is helpful, and we'll try to if you want to see this side, I'm sorry, so this side is this, and the other side I think it was visible from the beginning. All right, thanks for watching it. Bye bye.